brief question we have with the last session. Socket basically is a simple point-to-point connection. Socket basically is using internal ATC-PM socket, which is more secure. So this is when we say socket or socket, means it is all about connection mode from client to the forms. So either it is a simple connection or a very complex based on the TCP. So a simple connection is socket, which is fast speed, which is recommended all. In 11 it was default was socket. In R12 they changed it to socket, but again Oracle is only recommending to keep it again back to socket, change it to socket. Any other difference? I have 2 points that we already discussed. The advantages of this. Socket is for speed, but not for security. Subnet basically is very reliable. If there is some disturbance in the network, if the connection is blocked because of the network problem, the connection will be re-established. Connection can be re-established in a subnet, not socket. But again, see, like just if you want to see that feature, then you will get an everyday performance feature. So we may not have network issues every time. So we should not look at that. We should look at every time, like every second when there is something is going from the client in the forms, how much time it is taking. So what is good is socket. And we are going to see later like how you want to change from subnet to socket. And vice versa. You can change from these two things.
So once the service is handed over from Apache to OC4G or forms, the user starts accessing GL or any of the modules. So at this stage, still the Apache will be in picture or it is out of it?
See, as you said that like Apache will be playing a full role till PHP, personal homepage. When user is connected to personal homepage, yes, Apache will be able to play with it. And then Apache is basically rerouting the request to the container.
So always user goes to Apache then to whatever.
No. I'm saying that like not in that case I'm saying about the application wise I'm saying. So that is over, finished. The application, the Apache will reroute the connection to container.
Okay.
OC4 container. Either OA code or forms, whatever. That's it. Once it is handed over, there is no role of Apache. But again, if you go back to PHP, again if you want to access another application,
Then
again Apache will come into picture. So you must have, as long as the PHP is concerned, you are controlled by Apache. PHP means you are under Apache. And once you connect it to any application, then for that particular session, for that particular application, you are no more under Apache. But if you look at here, we will be discussing later, if you look at the PHP concept, personal homepage, is something like SSO, single sign-on. Something like single sign-on. This is within e-business suite. Within e-business suite, single sign-on. Most of the organization maintain SSO, single sign-on feature. The idea about the single sign-on is, in an organization when they have so many application modules, a user must log in one time, authentication must be one time, and then they can access different applications. Authentication should be one time for accessing different applications. So how it is done? Using SSO, single sign-on. So that's a different. In e-business suite also we can use SSO, that's it. But again, if you see, within e-business suite also we have so many applications. This is within across organizations now. But here within e-business suite, we have GL, APAR, we have iProcurement, Commerce, so many modules are there. If one user is going to access, let's say GL module, payables, also iProcurement. So user has to log in how many times? One time. One time. Authentication will be how many times? One time. One time. And once user connected to PHP, finish. From PHP you can go to GL module, again come back to PHP, again you can launch iProcurement. You understand? So once he is connected to PHP means he can select different applications.
It will depend on the
Of course, naturally. And that's what we already discussed. Which application user can access will depend on the responsibility. Right? But the responsibility from where is selected? From PHP. So PHP is a common part, right? Single sign-on. One time you connect to PHP, that's it. So again go back to PHP. Means again you are going back to PHP means you are going back to Apache. Not for authentication, but you can say you are putting a request to Apache, then now I want to select that. So when you want to select again iProcurement, now application Apache this time will reroute your request to what? Which container? OA code. OC code is a container, right? OA code application. So it will go to OA. So you were working with GL module and now you can also work with iProcurement module. If you have the responsibility, the user has the responsibility. But in authentication, it's done already, one time. Isn't it? So you understand? So to some extent you can say this PHP, the idea behind PHP is like SSO, right? E-business, within e-business suite, single sign-on. Just an idea. Within e-business suite. If you want to integrate various applications in an organization, e-business suite, in-house, SAP, and these and that, then there is something called you have SSO, single sign-on, which is a part of Oracle Application Server. Oracle Application Server. So now in Oracle Application Server we have SSO. So actually, any other Firebase application, OA code, instances, OA code, OA. OA code and stuff, what do you call this, forms and OA instances. The next, we have to look at what? Concurrent processing. Correct? Concurrent processing. So we discuss web services. We discuss under web services, the web or the web server, HTTP server, and the various OC porting instances. So let's continue with concurrent processing. So what we discuss with concepts. So here we are looking at the CMS. So here in terms of services, CMS, you understand CMS and even this application listener. This is for report review agent service, RRA, application listener, CMS. And then we look at multi-node setup, how things will be set up in multi-node environment, multi-node setup. And just a basic idea about, we'll do one thing, we'll compare R12 versus 11i or 11i versus R12. We'll compare 11i and R12. And there are other topics, but let us see this. Now, if you look at here, we discussed about this form-based application, HTML-based application, Java-based application, right? Now, apart from that, in business suite, there are concurrent jobs are there. The background jobs, the jobs which are going to be run by end users, the jobs to run reports, the jobs to run other various programs. For example, shell scripts or SQL loader uploading job, or maybe a database procedure. Okay? So there are concurrent programs on that. Your application module, most of this form-based application module comes with concurrent programs. concurrent programs, and user can run these concurrent programs. A user can run a report which is also called a concurrent program. And it is called concurrent program because this program can be run simultaneously by more than one user. A same report can be requested by more than one user. Same report. So this report is what? A concurrent program. It is running concurrently, simultaneously. And who's going to take care? All these concurrent programs will be taken care by CMS, Concurrent Manager Software. So this particular service is to take care of what? Concurrent programs. So before you understand what is CMS, you have to understand concurrent programs. Okay? Concurrent programs. So let's start with this. We are talking about CMS, Concurrent Manager Server. This is basically Concurrent Manager Server. Server or service, actually you can say server also, Concurrent Manager Server. This Concurrent Manager Server is going to take care of concurrent programs, isn't it? So actually if you look at this Concurrent Manager Server is nothing but, it is consisting of concurrent programs, okay? Concurrent programs. So Concurrent Manager Server is nothing but there are concurrent programs or concurrent managers are there. Concurrent manager. Concurrent managers. These concurrent managers are nothing but they are processes. They are processes. So what exactly these concurrent managers? These managers are based on processes actually. So what exactly these concurrent managers are doing actually? What is the use of this? What is the job of these concurrent managers? So these concurrent managers to take care of concurrent programs. Okay, so they are taking care of what? Concurrent programs. Concurrent programs, concurrent jobs. Concurrent, let's say first concurrent programs. Concurrent programs. So here you will understand the role of concurrent managers. Concurrent managers which are based on the processes. First you have to understand concurrent programs. So concurrent programs are first of all they are part of application modules like GL, AP, inventory. Each application module comes with concurrent programs. Okay. So these concurrent programs, example of this, what are the concurrent programs are there? A concurrent program could be a report actually, a report, RDF. It's a concurrent program, example of concurrent program. Or SQL loader job. Actually, basically it is called extension .ctl. You must have read from SCTL. SQL loader is also an example of a concurrent program. Okay. A database stored procedure. Database stored procedure is also example of concurrent program. Shell script is also example of a concurrent program. And there are many others. And even a C executable and all. But first you see this. At least right now, if you understand only one also enough right now. This part will be discussed in sysadmin module. So you first look at this. We are discussing from the base scratch. You look at this module. So where these particular programs are there? So these programs are there in various modules actually. Okay? Various modules actually. You talk about Oracle Inventory, Oracle General Ledger, Oracle Payables. It comes with various concurrent programs. So in Oracle General Ledger, forms are there. But not only forms, but concurrent programs. In inventory module, forms are there. Even concurrent program. HR module, order management module. So all these modules comes with what? Concurrent programs. Concurrent programs. Okay. So the example, reports are there. Even SQL loader programs are there. SQL loader for uploading data. Database stored procedure. Okay. And this. So how does an application module run these programs? As what? Concurrent. Okay. So if you look at the Oracle inventory module, let's say there are 10 users are connected to Oracle inventory module, 10 users. And in that inventory module we have a reports on it. Inventory item status report is this. The same report can be run by 10 users. That's why it's called what? Concurrently. Okay. So in that module, you will be having what? SQL loader will be there for uploading data. In that module, you will be having what? Database stored procedures will be there. So an application module, any module, GL, API, they are making use of database procedure. they are running database procedure, they are stored procedures. Where these database procedures are located? In database. But who is running these procedures? The application is running. How they are running? As concurrent. Okay. As what? Concurrent. Not only that, even what? Shell scripts. And if you look at the end users they don't need to be worried about it. The end users, when an user is going to run a report, or if an user is going to run SQL loader uploading job. SQL loader uploading job, you understand? How to upload data from a flat file into, how to upload data from non-Oracle to Oracle. From a flat file into database. There is a SQL loader program. And there may be one database stored procedure in the backend database which is doing some calculation, something. There may be a shell script doing something. But if you look at from the end user point of view, how end user is going to run? Simply by a concurrent. An end user will submit a request, is called concurrent request, and that request is going to run this concurrent program. And when this concurrent program is going to run, it is called concurrent job. When a program is running, it is called concurrent job, concurrent process or concurrent job. When 100 users, say each user is submitting one request, 100 concurrent requests, there are 100 concurrent programs are running. So first of all, these concurrent programs are part of each module, all the modules, GL, AP, AR, inventory, order management. So when you install already there, every module already has got all this, most of this already there. Okay. But end user doesn't need to know, oh it is SQL loader, no. End user doesn't need to know it's a stored procedure, no. Or end user doesn't need to know it's a shell script. He will just run a program. For user it is easy, simple. Because Oracle has provided all these as what? Concurrent programs. Okay. And later, suppose if any, for example, report is required to be added to any module, or if any shell script or database procedure required to be added to the module, that will be done by technical developer. Even we are not going to do that. Technical developer will do that. Again, end user is going to do what? They will simply run it. How to run it? Simple, that's it. Okay? First part. I'm talking from A, B, C, D. A, then B. You understand? You people say, I don't understand, no chance. This is A, B, C, D. What is module? What is program? So no jumping. No jumping, nothing. You have to understand. I will not ask you to understand or don't understand. You have to understand. Simple explanation, isn't it? Module coming with programs. You know, I don't understand shell script. I don't understand. Okay, don't worry. You don't need to understand too much of it. It's a program, basic idea. We are not going to do anything here. So one side we have concurrent programs. These concurrent programs are in general ledger module, or the tables module, or the receivables module, inventory module, order management module, purchasing module. Every module has got its own concurrent programs. Every module has got its own concurrent programs. And now we'll discuss, in detail we'll discuss how these programs, who's going to coordinate in execution of this program, who's going to coordinate? Concurrent managers. For running forms, we need what? Form service. For running Java application, we need OC4J, OA code. For execution of these, for to make sure that these programs are going to be run and all that, what we use service? CMS. So CMS is going to take care of this. So how exactly CMS is going to take care of this? We'll see. So we'll take example on this. So actually all this module comes with the concurrent program. So these are example of concurrent programs. And exactly when we say concurrent manager server means what? Nothing but concurrent managers are there. Okay. So what are the concurrent managers are there? Later we will be discussing this. This is not. The concurrent manager is nothing but based on what? Processes. Exactly. If you see, we already discussed that. Like there is a script is there. What is it? AD. Just to make you understand clearly. AD CM CTL.sh, isn't it? When you run this script, you are starting this service. You are starting concurrent manager service. What exactly you are studying? Concurrent managers. What is exactly started at OS level? Concurrent manager processes will be started. Okay? And what they are going to do? They are going to take care of what? They are going to take care of concurrent programs. Now we'll see that how user submit a request, okay? How user submit the request, how the request will be processed, how exactly the concurrent manager is playing the role. Now before that term actually, what is concurrent request? Concurrent request. What is concurrent request? A request to run a particular concurrent program. If a user wants to run a particular program, he has to submit a request. Concurrent request. Okay, concurrent. And concurrent job means concurrent jobs. Means a program which is running. It is called concurrent job. Isn't it? Concurrent jobs. Means don't get the term only. Concurrent programs are there, right? So when a user is running this, so a concurrent job is running. So to run a concurrent program, user has to submit a concurrent request. And when concurrent request is accepted, once it starts running, what we call concurrent job is running. And we have to take care of these jobs. How many concurrent jobs are running, which job is taking how much time and all that. Now first you understand the basic part. So you will be learning more about the CMS and sysadmin module. Right now only we are trying to understand the concept actually. What is CMS? Why CMS? Okay. What is exactly a concurrent programs? So exactly about concurrent managers. So here, first we have to understand how user, that already we discussed, how user first log into an application module. If a user wants to run any concurrent program, first user must connect to an application module. If a user wants to run a report, which is a concurrent program, in GL module, so first user must connect to GL module, from there he can run a report. Or he can run any concurrent program, stored procedure, whatever, which is there in that module. Okay. So first user must log into that module. First user must connect to that module. And then only user can run the request. Okay. So how users are going to log in? First, the whole story again, the PHP. When a first user have to connect to personal home page. After personal home page, user will set the responsibility. And then the form server will come into picture. And then the connection will be made. Now already session is started. Okay. And now a user want to run a request. Okay. Now user want to run a request. So see here. How requests are processed and what is the role of CMS. So see here. So here we have this concurrent manager service, which is nothing but, of course, you can say, technically speaking, they are nothing but processes. We have concurrent manager service. Okay. And here we have, of course, we have a service called the application listener, report review agent service actually. Application listener. This application listener is going to provide this service, report review agent. We'll see that, we'll take example of this. CMS service running, application listener is running. Okay. And here we have a database. We'll just try to understand the flow. And if you look at the user, first user must connect to what? Application, yes. So let's say the user, the end user is already working connected to an application module. Maybe say a user is already connected to, say, for example, Oracle inventory module. Oracle inventory module. So if user says that if it is already connected to inventory module, then already there is a connection established between what? Between form service and the form service what you have? What is running? Form. And the form service what is running for every connection? Form process running. This form process is already connected to what? Database. Which process here? Server process. So it is already there now. Right? It is already there now. So when a user is connected to an inventory model, it is there already. So then all these requests, user request is going to what? Form process to server process. And will be clicked. So this is the first part. First, a user must connect to an application module. And how user got connected here? First, what? It was PHP. Before PHP, it was what? Apache, authentication. After authentication, user get connected to PHP. And PHP, when the user select the module, responsibility, inventory responsibility, then this. Okay. And then still the PHP page will be there. PHP page will be there. Again, user can go back to PHP and user can select another responsibility. And that is what we are calling SSO, single sign on. Okay, single sign on. Once user is basically connected to PHP, user can launch multiple applications depending on the responsibilities. So user will be authenticated how many times? One time. Just I started today's session what is saying SSO, single sign on concept. Basically about single sign, one time authentication. So to understand, you have to understand from here, you have to understand. Now look at it. Now the user want to run a request, want to run a what? Report. So how users connected to this inventory model? Through what? Responsibility, right? There will be some responsibility. So in that inventory model, there will be so many concurrent programs already there. Reports are there, stored procedures are there, various concurrent programs are there. What user can run depend on what? Responsibility. So now user will submit a request that I want to run a so and so report. Okay? Now see this process. So in this particular module, in Oracle inventory module, so there is one screen is there, which is a common screen, common interface called SRS. What is that? SRS. Okay, let me write down here. SRS. There is a screen called SRS. Standard Request Submission. It's a screen. So if the user want to run any concurrent request, to run any concurrent program, user will open a screen or a form or a page called SRS. Standard Request Submission. So standard request submission is a screen and user will submit the request here. What is that? Request. Concurrent request to run a report. So here user will enter the name of the report, item, report, whichever. And then the user will enter the arguments. Argument, you understand? Like from date to date, he is running a sales report, some inventory report. And this request is to run what? Report, right? Report, right? In R12 we don't have report server. We don't have report server. We have a report server, executable is there, RW run. It's a file, not a service, not like process. It's not a service, not a based on processes, but a file, RW run. And then we also have what? All the reports are there, RDFs are there. So user want to run a particular report. Okay? So see what happened. From here, the user is connected, this connection, communication is there. From here to here, socket. Of course, it could be somewhere, but in this case, what is this? Socket. Here to here, net. Net DNS. Net DNS, correct? So between here to here, socket, simple point. Now user will submit the request. So request will go from this form process using the socket connection, the net connection. See the interesting. The request will go directly to, not directly but like this. We go to database. Our user want to run a request, a concurrent request. But where request will go? It goes to database. Okay, it goes to database. In database there is one particular table is there. We are going to see more in detail later. Okay, this is too early to discuss this. In system module we discuss concurrent request, FND concurrent request. So there is a table, it goes to a table, it's application table. Look at that. CMS will pick up the request. CMS will pick up the request. Request goes to database and CMS will pick up the request. CMS will check this particular request to run what? Report. It is to run what? Report. Then CMS will run it. How? Like this. Look at this. Using this executable, CMS will run this report. Who is running this report? CMS. We are using which particular executable? RW. In level I, there used to be, look at that, in level I, there used to be report server. Report server means report runtime engine process. Yes, there used to be a process. We need to start. There was a script called AD, REP, CTL for understanding. I'm just giving this. So there used to be one, we need to start a separate server. So CMS used to give this request to report server. And report server means report runtime engine process used to run the RDF. But in R12, no. In R12 we don't have this. In R12 we don't have this. Only we have a file. CMS will run with this. That's it. So we don't have that. So we don't need to start a report server. So in hardware, reports are not there. No, wrong. Reports are there. Report server executable is there. Report service is not there. We don't need to start the report service. That's the only difference. Okay. So look at that. And then next, what is going to happen? Then the executable, using that executable is going to run the report. But again, it has to make connection back to what? Again, make connection back to what? Back to what? Database? Server. Isn't it? Yeah, to run a report, database connection is required or not? To run a report, what does the report contain? Query. A report contains query. And now the report is running. Now the report is what? Running. So here in your database you have all that. Instance is there, listener is service is there, instance and listener both are there. Now the report is running. Now report is running. And what happened after that? The report will be completed and then output will be generated. That is what? File. What is that? This is, you can say what? Output file. Output. Output just file, output file. So for example, now where is the actual output, the report, where is the report output? In this file. Whatever, item status report. So user is running a report, item status report, inventory report, item status. So where is the report? Here, RDF. This is the report. But when this report is going to run, where the output is going to be stored? In a file. And this file, by default, this extension is what? By default it is text, txt. It can be changed to PDF. It can be changed to other formats. By default text. So user has submitted the request and now the output file is generated. And now user is going to view that output file. Okay, so first, what is the first part actually? A user using SRS must submit the request. This is all one part. One. Using SRS form, user will submit the request. Request will come to database. CMS will pick up the request. And CMS will pick up the request based on the timings. If the request date is greater than this date, it is called the request has been scheduled. So that means a user can schedule the request also. And when user say I want to run the report later, maybe after some time, maybe next day, then the request will be inserted here, stored here in this table, but CMS will not pick up. Because the sysdate, the request date is greater than sysdate. So that means you should understand that your CMS is also providing what? Scheduling. With this example you can understand. Say, it coordinate and schedule concurrent jobs. Now you can define it. What CMS? It coordinates and schedules. Both. It's a scheduler and it's a coordinator. The best you can write in your own words after understanding. See here, okay. Now look at what is the second part? CMS will pick up. Concurrent manager will pick up. So this part more detail in system here. How many concurrent managers are there? Which manager will pick up and all that details. Actually there are APIs are there. Oracle develops some APIs, application to through that API the request will be picked up. And there are so many managers are there, we'll discuss that. Right now you think a concurrent manager, which is the remote process. And then this concurrent manager will assign the run it. What is the third? Correct? With the help of RW run, it is going to run the complete report is going to RDF, complete, pick up and runs. And then final output is when we can divide it. Again, this is 4. Or you can say this is pick up the report and run. And then what is the output, where the final output is going to be stored? So when a user submits the request, the request will go to database and will be picked up and processed, and the output file is generated, and output file is going to be stored in some directory, or that also we are going to see in file system. And now the output file is there. And now user can how did user submit the request? From SRS. And from this SRS, user can monitor the request, whether the request is completed or not. And once user sees the request is completed, now user can see the output file. And now we are going to see the next part, how user is going to see the output. So first user must submit the request, wait for the request to be process completed, and once the request is processed, and user can view, user can access that particular output file. The next we are going to see that next. So how user can see their output. But physically where is the file? It is on server side. Here it is not client side, server side only. CMS, in CMS. Now you understand, is CMS is running the request? No, actually there is a executable is there, but CMS is doing the entire coordination. And then so you may say, why it is like this? Why not direct? So actually, you know what? This is called asynchronous processing. So this actually want to develop this feature concurrent managers, all these concurrent managers for asynchronous processing, for async processing. And this async processing is like, you know, for guaranteed processing, for guarantee. It is for guaranteed processing. There will be a little delay, but guaranteed processing. So it is like this. You see, not direct, but through database. So you know, like, for example, if request is running, and suppose suddenly if instance goes down or if there is service goes down, so the request got terminated, cancelled, okay, and now we will restart the service. Again, when the service restarted, does user need to submit, is user required to submit request again? No, because user submitted the request here in the database and the status will be maintained in the database. Okay, so it is called guaranteed processing, means even if the request got terminated, again it is going to restart. Okay, so for example, when the request is running, all the services go down, and when you restart the services, again your request will rerun. So user need to submit request only one time, and it will be processed by guaranteed process. Asynchronous guarantee. And see, so many advantages are there. A user will submit the request. After submitting the request, actually user will get request ID. So this is like an acknowledgement, request ID, that your request has been accepted. And then it will be accepted and processed. And if you see, a user can submit multiple requests. He doesn't need to wait for one request to be completed and then second. The next, user can close his application. User can close his application and user can do something. User can switch off his system. If user disconnect himself, if switch off, his request is processed or not? Request will be processed. So user will submit the request, one or couple of requests, and he will switch off, disconnect. He will be doing some other thing, and his request will be processed. So this is asynchronous model. Asynchronous. In background, the request will be processed. And it is not from one user, it may be hundreds of users. Imagine. That's why it is called concurrent. There are hundreds of requests coming to what? Database. FND concurrent requests, hundreds of requests. Hundreds of requests will be picked up, and this CMS is going to process or going to take care of hundreds of concurrent requests simultaneously. That's why concurrent. The word used everywhere, concurrent. Right? And next, you have any question, ask me. The next now, how user will pick up that file, how user can see, view that file from the browser. Okay. It is phase-wise. Submit the request, wait for the request to be completed. And how does user know? From the same screen. This is a form screen. And this part you just don't write down, don't get confused. This is 11i, right? So that will be again discussed. So in 11i we have what? Report. This R2. So user, and one more time, user cannot submit, cannot enter request. Yeah, there is a way there, but generally end users will submit the request by logging to their application from their GL module, from their AR module, from the inventory module. From that module, they will submit the request, and then direct request will come to database and pick up and process. Any question you have, asked me. And now you can understand. Let me ask you a question. You are not asking me, you will ask me. Simple rule. You don't ask, I will ask. Listen, if concurrent manager is not running, look at this and tell me. Can user submit request? How yes? Why yes?
Will that be submitted?
Why yes? Why?
Request and submit the database, not database.
Very good. This is your decision. Because requests are going to database and then later it is picked up. So even if application services are not running, means which application CMS is not running, reports is not there, or the other services are there, still user can submit the request.
They will get the notification.
Yeah, acknowledgement, yes, that your request has been accepted. You see that? But at least forms must be running, right? Forms, because even if forms is not running, user will be able to submit requests. There are APIs have been given. There are APIs. There are concurrent programs, or there are some PL SQL packages have been given, which can use to directly submit the request. Even for that only what must be running only? Database services. Not even Apache. Database services. Instance and Disney. A request can be directly inserted through some API. API, we'll see later. API. Request will go directly into the database. But request will not be picked up and processed because CMS may not be ready. And today you submitted, later whenever you start the application service at that time, again immediately CMS will pick up and process. If the request date is past date also no problem, it will pick up and process. If the request date is a future date means it is a schedule, it will not process. Less than, if the request date equal or less than, it will pick up and process. Request date is less than or equal to sys date, pick up and process. If the request date is greater than sys date, means what? Future date. Yeah, it has been scheduled, run later. Now I am going to tell you about how user can see this particular output. See, now in the same screen, there is a status is there, and there is a button is there called output button is there. So easy for user. Okay. Now user will click that output from this screen. Output. Now user can view that file. So when these users submit the output, now look at here who will come into picture. Application listener. So application listener providing which service here? Report review agent service. It's a report review agent. Report review agent. So this request will go to what? RRA, and RRA help the user to view this file in this where? In the what? Browser. You don't write all this, just say RRA. So user can view the request output file with the help of what? RRA, report review agent. If report review agent service is not running, can user submit request?
Yes.
Request will be processed?
Yes.
Then what is the problem? Request will be processed, output file is generated, but user cannot view it. So all are separate, independent. If application listener is not running, user, everything will be done, but user cannot see, user cannot view, user cannot access the output files. So they are independent. So now you say, I'm asking you, you think that CMS or application listener depends on what? They are dependent on it, independent. So application listener depending on what? CMS. So where application listener should be running, in which machine? In multi-node, where CMS is running. So they are independent services, but they are dependent. Like, isn't it application listener depend on CMS? No, because who is generating this output file? CMS. And how user can see? With the help of application listener. So just understand that they are separately. We are studying CMS separately. We are studying application listener separately. But they have to be together. Actually, dependence. Just an idea, dependence. So now you understand. So the output file is generated, and later, anytime, when user want to see the output file, user will send a request. Just click that. Request will go to RRA, and RRA is going to. But when a user is going to look at the output file, this is interesting. The output file user can see from here, but physically it is not here the file. Only the view. Physically where it is? Server. And user can save it locally in the desktop, or just can view and delete that. Or user can send this request, and user can send this output file to printer also. That is also there. There is a request file. Okay, that we'll see. So user will submit the request and say go to printer. So file will be generated, and when the file is generated, the concurrent manager will send the file to printer. Okay. So user can do printing. In that picture you will understand here. Okay. So now you understand the two things. With this all explanation diagram, only what is CMS, what is the role of CMS, what is that's only we want to tell. Nothing more than that, isn't it? With all this explanation only to explain what is CMS or what is application. That's it. And
With the output file in the database tables or in the file system?
how can you put table file? File is a file is
In the file system.
file system actually. File is file. See, again the same time, all the requests are going to this table and this table will be growing. And all the files will be, so hundreds of files will be generated. So later we must purge, delete. By default it is not going to be deleted. Okay, by default it is not going to be deleted. So the files will be growing, there will be many files generated and lot of data. So this is concurrent request data, but it must be data purged. So we'll see how to purge that. Now let me also add this. Is it the CMS playing the role only for report service? No, not only for reports but also for other services. Now let's see also here. Let's see SQL loader job. Okay, we can say SQL loader job. So you know what? For SQL loader, here we have like the RDF. What is the file here? You have CTL. And what is the utility here? SQL LDR. SQL LDR. So SQL LDR is an executable file, and this is your SQL loader control file. And we are going to upload the data from where? From which file? From a flat file. And the flat file must be in the server. What does the flat file extension say? That. Into the database. So this SQL loader control file contains the information about the DAT file as well as the table. So generally SQL loader utility read the control file and it will pick up this DAT file and transfer the data from this DAT file, is a flat file, from this file into the database table. When you are running directly, when you are running this SQL loader directly, this is how it is going to work. But now just see how end user can run it. The beauty here is that end user doesn't need to know what is SQL loader. End user doesn't need to know what is a CTL file. Now this is a fully encapsulation through concurrent jobs. So this is what we are calling, this is now we are calling concurrent program. This is we are calling concurrent program. So it will be available. Okay. So already this module comes with concurrent programs. How users are going to run? Now see. Again user must submit what? Requests. How user can see the information? From this screen, SRS. So user can submit the request, whatever the name. And the name of the concurrent program is upload data, upload item information. Something simple. For user it is easy. Upload concurrent program. So request will go to this database. Who will pick up? CMS. And now CMS will assign this job to SQL loader. And SQL loader is going to read what? CTL file. And after that what it is going to do? It is going to read CTL file and it is going to upload data from this DAT file to this database. And after that SQL loader will tell to CMS that I have done my job, finish. And then of course it generates what? The output file, the log file will be generated. What will be generated? The log file. The log file, output file, that the job has been done. And now how does the user know that my job has been done successfully? By accessing that particular log file. How user can see that log file? With the help of R. Okay. So whether it is a report or whether it is a SQL loader concurrent program, all the requests will be going to CMS. And CMS will assign either to reports server executable or to SQL loader executable, isn't it? Or maybe there are other concurrent programs, other shell script and other. Okay. So it is going to SQL loader. So SQL loader will do that. Okay. As an absolutely at least you must know what is SQL loader, what is CTL. That's it, nothing more than that. You are not going to do all the job. Developers will do it. Who will develop with all these custom developers will do that. But we must know CTL means SQL loader control file. And where is the flat data? It is in that file, flat file. And there is a utility, it is SQL LDR is a utility for uploading data. So here also CMS. Request is not going directly to SQL loader. Database, CMS. So for any concurrent program, the CMS is playing the central role. Right? So now you will be learning more about CMS. This is basic things. Later in sysadmin model, more about CMS. More CMS. essentially just remember. You don't need to remember all this flow. It helps you with this flow. Nothing. That's the idea. How users run the report. And here later, you know, why we have to know all this? A user will call you and say that I submitted my request is not running. Coming to our job, we are not concerned with this, but what is our job? I will tell you. A user will call you. I submitted request. My request is not running. So is it stuck up in database? Why CMS is not taking that? We have to check. What type of request it is? We don't need to know. Whether it is going to run shell script or we don't need to know. What that shit? Oh, we don't need to know. What this? Oh, we don't need to know. What this? Oh, what? We are not concerned. What is this? Oh, we are least bothered about it. We should not know nothing. What it contains? We are never concerned. We should not. Just an idea. But user said that my request is not running. Check here. Check, CMS is running. My request is running, but the status is pending. So maybe some problem with CMS. First problem is here, second problem here. So we have to check the status of what? Concurrent manager. So in sysadmin module you will be learning. So how to check the status of concurrent managers, how to check, and why a particular request is taking more time, and that's all PTR. Or is it a request is waiting for some locks, internal locks are there? My request used to, my report, whenever I used to run a report, it used to take 30 seconds, 40 seconds, within maximum 40, 50 seconds used to run. Now my request is running from last 10 minutes. This is the question posed by end user. So you have to go and find out the detail. Why it is taking more time? Is it because of some logs? Is it because of some real performance issues? Or it is in the queue, still the request is in the queue? So actually in e-business suite, it is divided into two. Online processing, the entire e-business suite processing is divided into online processing and concurrent processing. It's two parts, online processing and concurrent processing. Online processing means we say the users who are directly connected to the forms, who are performing transactions, who are using forms, who are using HTML pages. Okay, online processing. Those users who are entering sales order, those users who are entering purchase order, those users who are using whatever, but they are using forms, they are online users. You must understand what is online users. And those users who are running reports or any background jobs, any concurrent jobs, they are background users or concurrent users. Concurrent jobs, sorry. They come under what? Concurrent processing. For example, if you look at in any organizations, most of these concurrent jobs will be running. Like say for example, there is a manager, a senior manager, a vice president. So are they going to perform some transaction? Are they going to insert data? Are they taking care of any transaction? No. They will be running only reports, right? So they come under what? Concurrent processing. And this is very important. Like we have to maintain balance between online processing and concurrent processing. As far as the resources are concerned, okay, how much online users are taking resources and how much the concurrent processing, background jobs. So entire e-business suite processing is divided into two, online processing and concurrent processing. Concurrent processing will be all in background. Concurrent processing. So you got it? So in most of the cases, user cannot run request directly. They have to follow this process. They have to submit the request actually. Submit the request and wait for the request to be completed. And this is how the request is processed. So here we have discussed two things, CMS and application design. So now you understand what is the role of main application design. For what? Report review, agent service. Report review. Now let's look at the multi-node setup. How we can set up e-business within a multi-node environment. So we discussed the overall already the main unit as services. We also discussed in single node, right? Single node. So when you want to install in multi-node setup, multi-nodes. So let's say you have one physical box, and now you want to go with, say for example, two nodes. You want to go with the two nodes. So first, the OS, operating system. You know what? In multi-node, your OS operating system can be different. Okay. So let's say here we are planning to have, you know what? some services. Here we are planning to have some services. So you understand, in multi-node, your OS can be what? Different. This is called split architecture. Recommended is same. For example, here you are going to have RHEL. Here, what is recommended? You know, RHEL. Same recommended. But if you want to go with a different operating system, this is called split architecture. And Oracle E-Business Suite support split architecture, but it's not recommended. Yeah. Split architecture is supported, but not recommended. So each node having different OS, yes, supported, but not recommended. In terms of patching, in terms of cloning, maintenance will get difficult if the operating systems are not same. Okay. Patching is a difficult, and there are other difficulties you may face if the operating system is not same. Somebody may go for split architecture, only one builder. What would be that? Split architecture is not supported, but still somebody may go for what? Somebody may go for it. What could be the reason? It is not supported, but somebody is going for it. Why? What do you think? You don't think? I think. What I think, if you don't think, you see, you don't see. What I see. What I think, if you don't think, is cost cutting. Yeah, tension mat lo. Cost cutting. What is that? Cost cutting. That's the only reason. Otherwise, same was. If you're going for window, see, no, I will go for what, for example, Solaris. Solaris means what? Hardware power. Like hardware must be Spark. But if you're going for Linux and Windows, you can go for Intel hardware. So only for cost cutting, the different OS might be selected. Split architecture is maybe selected, but it is not recommended. So first, we start with it. Now, you need to decide that we have two physical nodes, what you would like to keep here and what you would like to keep here. Now, you see the production environment I will show you. In a production environment, those organizations who are using two nodes, worldwide, maximum companies using two nodes. Number one is two nodes. There are some production environment running in one node also. Don't think that one node is only for, no. There are production environment running in one node also. Database, same box. Application, same box. There are production instances running in one box also. Majority worldwide, two. You find there are 8 nodes are also there. 4 nodes, 8 nodes are there, but majority, 2 nodes. Okay? And within 2 nodes also you will find some differences. For example, this node is for DB tab and this is for application. Again, there will be some change. So this is what? Let's say for example what? DB node. This is which node? Apps node. So here we are planning to have complete DB tab. So here you have what? Entire RDBase binaries, your Oracle RDBase binaries and your database. And your complete application will be here. So what are the application here you are going to have? So in application side, you will be having complete, you know what? So actually it is called, you know, the services. You have this, actually it is called, let me just add that. Complete application, what is that? Upper top. It is called what? App stack. The more technical term, it is good later for you, it is easy to understand. App stack, okay, and tech stack. App stack and tech stack. App stack means Apple top. These are the application file system. Apple top, also common top, common top. COMN, or you can say just common top in short, or common top. Let's say common top. It's called app stack. App stack means Apple top, common top. These are application file system. All application files will be here. Apple top, common top. Tech stack, we already discussed. Tech stack is what? 10.1, 10.1.3, 10.1.3 home, and 10.1.2 home. And plus what you have here? INST top, which is called instance top. Instance top. But in terms of services, these are files installed actually. So your RDBMS and database. So your every application files are here in this node, apps node, machine is apps. Abstract is upper top, comma top. So upper top, comma top, these are the top directories which contain all application files, and we are going to see more in detail about these application files. Application forms, Java, and all that files are here, physical files, upper top, comma top. And you also discussed that the application services will be running in a different home, your 10.1.3 home and 10.1.2, which are text stack. And all your application configuration file, Apache configuration file, what's the name? Apache service configuration file. http.com. Where is it? INST. Form service configuration file. Apps web.chg. Where is it? INST. All the instance configuration file. Instance configuration file will be under INST top. Instance top. We'll discuss more in detail. So you know what? Again in e-business suite, technically if you go now, this also, look at this RDBMS home, actually it is called tech stack only. This is what? Tech, please don't know, no? This is actually tech stack. And this is called app stack, please note on it, app stack. So what is your tech stack? RDBMS home. What is your app stack? Database. But this is under what? DB tab. This is what? This is DB tab layer. And this is what? Application tab, apps tab. So listen, under DB tab, tech stack means RDBMS. Under DB tab, app stack means database, application. Under application tab, app stack means upper top, comma top, and tech stack is 10.1.2, 10.1.3. So here you have app stack and tech stack. Here also you have tech stack, app stack. So they wanted to make simple. DB tab, tech stack, app stack. Application tab, tech stack, app stack. Simple. And then separate configuration. The separate configuration is INST. What is the technology of your database? Tech stack. Your RDBMS home is the technology. So RDBMS home is known as database technology stack. Tech stack. And what is the application of this tech stack? Application. What is the use? What is the application of this? Why do you install this? For creating what? Database. Database is the application. No, don't get confused. Front-end application. No, don't get confused. This is general term. Application. What is the use? What is the application of RDBMS home? For database. Creation of database. So your database is called application stack. So two stacks are there here. Tech stack, app stack. So don't get application stack means within DB tab. Within DB tab, application stack means database, all database files. Okay. So DB tab, tech stack, app stack. Application tab, tech stack, app stack. Tech stack, app stack. So here your tech stack is RDBMS home. There tech stack is 10.1.3, 10.1.2. And now you know very well that here what is the tech stack? What is the version? 11.5. What is that? 11.19. So RDBMS home. We are talking about R12, 12.1 now. We are talking about 12.1, 12.1.0. In 12.1.0, what is your RDBMS home? 11.1, 10.1.3, 10.1.2. Now look at it. Tell me. Where we can start instance, where we have to start that database instance, where? In which node? DB node or apps node? DB node. Why DB node? Why DB node? Because RDBMS home is here. So you will be starting instance and listener under which location? Under RDBMS home. That is under tech stack. Why you can start instance and listener here? Because here we have tech stack, your database tech stack, RDBMS home is here. You can start database instance and listener here only, not there. Because your RDBMS technology stack is here. So you have to start instance and listener here only. Clear? Now, this part you know actually, just you know database, just tell you like that. Application, where you will start application services? Tell me where you will start Apache service and OC4J instances, where? In this machine, apps node. Under which home? Apache. and OC4J. Where? Which home? Which home? Tech stack. Under tech stack, which home? 10.1.3. And CMS 10.1.2. We already discussed now here. Which services will be under 10.1.2? Which services will be under 10.1.3? Your Apache and OC4J OAcore will be running under 10.1.2. Your forms and CMS will be running under 10.1.2. Sorry, Apache 10.1.3 and forms and CMS 10.1.2. So this is physical files, all files are here. Actually then we have to start the services. So only installed files are DBMS binaries and data files, no services. Only installed application files, technology stack and application files. Now what services we have to start here? Look at here. So now these are the names, app stack, this is names only, this is app stack and this is tech stack. Now what you have to start here, what are the services you are going to start here? Instance. For example, this is production, whatever, instance name is production, whatever. And then you have to start what? Database, listener, safeguard. Look at that. What are the services here you have to start? Okay. So let me just take out these names. I'll just keep actual names. So every time we will not write Apple Top, App Stack, you can understand, only they are names. So we'll actually write the main file system. So what are the main file systems are there? The main file systems are what? Apple Top, Common Top, and INST Top content configuration. And what are the binaries homes are there here? 10.1, yeah, 10.1.2 and sorry, 10.1.3 first, let me write down. 10.1.3 home, and here we have 10.1.2. Okay, so what will be running under 10.1.3? Apache service. You will be starting Apache process, HTTP process, Apache service, Apache processes, Apache listener actually. You can say Apache listener process. Apache listener process will be there. And then next is what? OC4J, most of the OC4J instances will be running here. If it is form servlet, it is running here. But let's say OC4J OAcore, only will take OC4J OAcore. And forms socket like that. So where is forms running? Forms, I'll tell you more about this. Forms service is running here. CMS is concurrent manager service running under here. CMS, application listener. So in short, you can say all the application service running in this machine. Okay, only you have to go down. Which service running? Apache, OC4J, OAcore, forms and CMS. We already discussed. Only you have to run this which home actually. So Apache listener and OC4J, OAcore, 10.1.3. Form service, CMS, application listener, 10.1.2 home. So you'll be starting from this home only, okay? And then where are the physical files? All the files under Apple Top and Common Top, all application files. Configuration file is under. And where are the binaries? Separate. 10.1.3 binaries, 10.1.2 binaries, and that is RDBMS binary. And the name also we discussed, right? Can you tell me anybody 10.1.3? What's the name of the home? You can tell me 10.1.3. So that you have remembered. That's very important. Web home. And this is what? Remember that. This is what? Web home. And this is what? Tools. Web home and tools. Web home also. And it is called Java also. It is called C also. C home and Java. Name. This is like a understanding more in detail architecture. Exactly which service is running under which one. Last. Visible, clear? You can read it, huh? Font size increase?
No, sir.
No. And on this basis, you will understand multi-node also. But this is, see, for application, how many node? One node only. Now for application node, how many node we can go? We can go for 2 node, 3 node. This we can split into physically 2 node, 3 node. Isn't it?
later also it is done on a single node machine.
Yeah. You can initially single node, you can go to 2 node, 3 node later. For example, this 2 node, later you can add another node.
And configure those.
Yes, it's perfectly easy. Nowadays in R12 it is more easy. Easily you can another node, copy the files and configure the service. It is so easy. Copy files, configure service. Very easy. Scalability. It is called scalability. Initially you have 1 node, you can go to 2 nodes, you can add 1 more node, scalability. Okay, now you see here now, every application service running here. So some of the production environment you will find like this. But some of the production environment you will find something different. You know what? They prefer to run CMS, of course application is run here, along with the DB. Reason I will tell you, just now we discussed that, for let's say you know that these 2 machines are connected to the network. There is a network, this is your network and these are your end users. Okay? So this is your network and these are the clients. And you don't worry about the connectivity. Yeah? So the Apache and all that, they will connect to this listener. So there is an address is already there. And it's very simple, you people know that. In 10.1.3 home, in 10.1.2 home, you have the TNS services there. You have which file? TNS names.ora. For your understanding that. And there is a TNS services there, which is the providing the address of this listener. So it doesn't matter whether they are running the same machine or second other machine. So there is an address is required. What does Apache, what does Forms need? Address of listener running in any machine. And that address is provided in this file, TNS.ora. In the TNS.ora, you have a TNS service. And the TNS service is also based on the same name of the database. Production database will prod, instance name will be prod, listener name will be prod, TNS service name will be prod. So this is file. Okay. So how many TNS.ora file here? How many? Depending on nothing. You can say exactly. So total how many TNS.ora? Two. For 10.1.3, 10.1.2, yeah? Not for RDBMS, all is same. For 10.1.3 and 10.1.2. So after 10.1.2, there is a for 10.1.2 and for 10.1.3. There are 2 TNS.ora files, which is giving the address of what? Listener. Because I know this question comes to mind that, oh, they are in different machine, so how it is connecting? No, it doesn't matter. They are client. Now, what is preferred here is, if users are submitting requests, the request is going to database. And CMS will all the way network every time. Oh, there is a lot of network traffic. It is okay. If you have a good network bandwidth, okay. But isn't it more network traffic because of CMS? Every time CMS will go and pick up request. And when the request is running, when the status is changing, when you submit request, the status is pending, running, completed. So every time the status will be changed where? In database. So there is a lot of interaction between CMS and database. How we can reduce this network traffic? By keeping CMS here. Okay. So some of the organizations, I'll tell you what they do actually in some of the production environment, we have done that. We recommend that. Okay. That you keep CMS here, you keep application here. But some organizations, there's a rule actually, we don't, for security purpose, we don't want to mix anything in this production machine, only database running, so don't mix anything. In that case, this is. Otherwise, if security will be there. If it is okay, then you are allowed to keep application along with the database, which is not going to create any more security problem. But still some organization think that what we should do, look at it. Now we have to keep complete application here. We have to keep complete application files here. What is the complete application when we say? Complete means what? Complete, Apple top, common top, and then INST top and tech stack. What are the tech stacks are there? These are tech stack, eh? Tech stack. These are, you can say, tech stack. In short, I will just, okay, it's okay if I can say what? Tech stack. What's that? Tech stack. Complete tech stack. Apple top, common top, tech stack, and complete. Here, complete here. Then, what we can do? We can configure which service here? We can configure service in terms of service, CMS, and application And then this will define. It will be single node means what? Yeah. So this is two node, but application this is what you call this up to this is called what? Abstract. This is also what? Abstract. This is abstract, that is also abstract. Abstract, abstract. So we are keeping complete application here, complete application files here, but service, which service we are configuring? Only CMS, an application user. And now the request, user submit the request, it will go to database and who will pick up? Yeah, through listener only, of course, here. But is it network traffic required here? Network traffic is not required. It is the same. It's a good idea. It's a good keeping CMS around, not mandatory, but it is good. Because you will find the production environment running in two nodes, both you will find. If you go to some organization, you will find they are keeping database application separate. In some of the organization, you will find this is much better. This is much better. This is good. In terms of performance, this is very good.
So except CMS, all the services will be remaining.
Then except CMS, your forms, your Apache and all that. And here CMS will be running on the tech stack. So tech stack is there already. What is that? 10.1 to home is there. So 10.1 to home here, 10.1 to home here. 10.1 to home here for form service. 10.1 to home here for. But the downside here is that every file will be repeated. Complete upper top, common top, complete application, tech stack and complete file system. But it is okay, no problem. So service. Now you can configure any service here, you can configure. For example, later you don't want to run form service here, you want to run form service here. Within no time you can do it. Within no time. It is so easy. And we are going to see that. Again you decided I want to run CMS here, no time you can do it. Within no time you can do it. Very easy. But now let us change the name. Instead of calling this name, what we can call DB apps, correct? DB apps node, DB apps 1 node. DB apps 1 node. This is apps 2 node. Any name, meaningful name. So now this is DB apps means it has got database as well as application. So in one machine. Here only very big. So simple, you can keep separate or mix. But again, if you are asking me which service we have to keep in database, not forms, not Apache, only what? CMS, because of dependency. The remaining better you keep here. Now I am asking a question here for you people. We are going for 3 node. So which one you will take out? You tell me, which one you will take out? 3 node. Now this is fixed, huh? CMS, this is 3 node, which one you will take out? Which one you will take out? 3 node. Wait. Hold it, tell me.
I will completely replicate that machine.
Full service. You have to keep there is no option, you have to keep complete application. But this service.
Web.
You are saying web means or
Apache.
for the Apache and in terms of service. I'll tell you, the moment you decided to keep everything, you have to keep complete application, you have to keep. What is that? Complete upper top, complete common top, complete tech stack as well as INS2 top. Complete. There is no difference here. What service you want to run, you run. That is okay, different. So this is called unified application file system. Unified application file system. In R12, not in level. Unified application. Every node will have complete. You configure this service, you complete this service. Which one? Forms? Somebody saying that I would go with forms. Those who are saying forms, I said forms. So when forms is what? So forms will not be ready. So physically we are not removing any file. Please understand, we are not removing physical file, only service. And service there. We disable service there, enable service here. You know what? Here only question enabling, disabling service. That's it. Keep application complete files, enable service, disable there, enable here. Later you want to go back. You disable here, you can enable here. Because complete files, everything is here. Enable, disable. Now 10.12 home. 10.12 home will be there. 10.12 home is there, but maybe somebody not using it. Okay, no problem. But everything will be there. But don't worry, like we have a topic file system, here I am going to discuss more. So we are only discussing in terms of services, in terms of 2 node, 3 node.
Multi-node structure, applying patches difficulty.
Yeah, patches difficulty, yeah, but we can't look for that, right? That's a one-time difficulty, but every time performance will be good, right? Scalability and all that. Now see, you have to apply patches on application 3 times. This. But again, there is a feature called shared application file system. Shared. In that again, very easy. Multiple node, but you can keep all the files in one common location. How many upper top? Common top? 1, 2, 3. You can keep one upper top in the shared storage, and that is called shared abstract. Multiple node, but how many upper top? One upper top, and that one upper top can be shared. And now you have to apply patches one time. Then again it becomes very easy. So this is without shared abstract. I am going to tell you that in file system we discuss. Here exactly our discussion is not for application file system, for services. So you understand in terms of services. Any question you have? That's it for me today. That's it. Any question, please? First, you have to make your basic concept clear. Huh? You understand the basic role of CMS, concurrent manager, application listener, Apache, form service, basic level, at the basic. What is the role of CMS? What is the job of application listener, code review agent service? And initially you can, if you want to see, I don't see any good book in the market for Oracle application. So only if you want to read material, the one which we I think have provided here, you can refer that. If you want to read any Oracle material, it is concept guide. 11i, R12 concept guide, where everything is covered in concept guide, which you can download freely from OTN site. You go to Oracle documentation site and documentation, Oracle OTN site, odn.oracle.com, you can freely download. First you have to download which document, then the PDF is there, 11i R12 concept guide, concept. Sysadmin, installation, patching, cloning, upgradation, everything complete. A to Z documentation is freely available. Initially you have to refer to what? Concept guide. Okay, and don't get discouraged, you will understand that. After attending these all classes, if you refer that, then you will understand. Don't have to do this. Initially you have to refer to concept guide, concept guide. Everything is covered here. What we are discussing. So don't worry, we will discuss more and more. This is very good concept. Understand this concept. And there are file system, data model we have to discuss. And this is without load balancing, without shared abstract, load balancing also we see, shared abstract also we see. And this concept is you have to understand this upper top, common top thing. What are the files are there in upper top? What are the files are there in common top? What does exactly text stack contain? This is very important. So next.